Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge: minimum, size, subarray, sum. Given an array of positive integers, nums, and a positive integer, target, return the minimal length of a subarray. And a subarray is probably pretty much what you're thinking it is: a contiguous, non-empty sequence of elements within an array. All right. Return the minimal length of a subarray whose sum is greater than or equal to target. If there is no such subarray, return 0 instead. All right, get some examples here. This one, for example, here's the input. The target is 7. The output is 2 because we have a subarray right here. Whoops, right? Come on. Right here. 4 and 3 equals 7. So subarray is 2. What is this one? Oh, I see. Yeah, you can hit 4 with one number, and this one you can't hit it at all. So we output 0. Target is somewhere between 1 and a billion. The length of the input array is up to 100,000, and thus the size of the numbers is up to 10,000. If you figured out the O(n) solution, try coding another solution, which the time complexity is O of n log n topics. Array, binary search, sliding window, prefix sum. There is another solution that you can do with prefix sum, binary search. I don't know, maybe that's an n log n solution. We're not going to do that. I mean, we're going to do the sliding window because sliding window just seems like the more natural approach to this. Even if you've never heard of sliding window, it seems like the most natural approach. So let's see what that would look like. All right, so this is the input from example 1. We've got a variable here called min, and we're going to initialize it to 1 greater than the length of the input array. Now, if we go through the input array and that number, the min, never changes, that means we were not able to find a subarray that hits the target. So in that case, we're just going to return 0. We're going to start with 2 pointers. Initially, both are pointing at the first element, and we're going to sum up at each step. We're going to sum up the numbers within the windows between the pointers, but counting the number that the pointers are pointing to. So in this case, we've got a window of size 1, and it adds up to 2, which is not big enough. Our target is 7, so we need to move one of the pointers forward. Let's move it up here. And now we have, in the window, we have 2 and 3. That adds up to 5. It's still not big enough. So we've got to make it wider. That. This is going to go here. 2, 3, 1, 2, 5, 6. Still too small. All right. Get rid of the pointer and enlarge the window further. Right here we have 2, 5, 6, 7, 8. Okay, so that hits the target, and it's smaller than what we have for min. That is a 4-element window, so we'll get rid of this, and we'll say the new min is 4. Now we try to squeeze the window in from the left. Okay, so erase this pointer, and move it in a little bit, move it in one position. Uh-oh. Okay. Roll it back out. I just want yellow. All right. Right here. Yellow. All right. Now what have we got? 3, 4, 6. Too small. So we got to enlarge the window again. That pointer. And move it over one. Now we have 3, 4, 5, 6, 10. Okay, that's big enough. It's not any smaller than the previous min window though. So we're going to try to shrink the window from the left. All right. Move it in one. Now what do we have? 4, 5, 6, 7. All right, that hits the target. It's also smaller than the min window that we had. So that min is gone. The new min is 3. All right, let's try and squeeze it in a little bit more. Get rid of that. Move it in one. We are right here. 4 and 2, 6. It's too small. We need to make the window wider again. 4 and 3. And move this over. Now the window is 2, 6, 9. It's big enough, but it's not smaller than the min that we already have. So we try shrinking it from the left. Okay, that. All right, now we have 4 and 3 is 7. That does hit the target. It's smaller than the min, so the new min is 2. Okay. We will try to squeeze that in again. And we have pointers here. We're at the end of the array now. We have a 1 element window. 3 is too small. So our min is 2. Min is 2. All right. What would that look like? What would that look like if we tried to code it? All right, we need a variable. Well, actually, first let's just get int n equals nums.length, so we don't have to keep referencing it. Okay, int n is nums.length. We need a variable for the sum, and because some of those numbers that we looked at in the constraints were kind of big, target up to 1 billion, 100,000 elements, 10,000 size, I don't know, just to avoid any unpleasant surprises, let's define the sum as a long. And the min length, as we discussed, is going to be min length is going to be n plus 1 initially. If it never changes from n plus 1, that means we couldn't find a subarray. All right, now we can do the for loop. So for int, we need 2 pointers. Let's call them start and end. And we're going to keep going as long as end is less than n, and we're going to increment end as we go through the loop. All right, calculating the sum. We're going to add to the sum the current element, which is nums end. Again, initially, start and end both point to the element at array 0. So first time through, we're just going to add first element of the array to sum. All right, now, while start is less than n, and we got to keep the start index in range, and sum is greater than or equal to target. All right, this is not going to apply sometimes. As we saw in the example, I think it took four iterations before we were able to get a sum that was greater than or equal to the target. But if we do get a sum that's greater than or equal to the target, then we want to check the length of the window. So min length will equal math.min. It'll be the minimum of whatever the min length currently is, and end minus start plus 1. So a min length, if we are able to get a sum greater than or equal to the target, then we're going to check the length of the window. If it's smaller than what we already have, then we're going to reset min length to the size of the current window. Okay. And we are going to try to shrink the window from the left. So sum minus equals nums start and increment it. So we're going to increment start, but not until after we have subtracted the first element of the current window. We're going to subtract it from the sum, and then we're going to move the start pointer to the right. Okay. And then we'll go back up to the top of the loop. And if the sum is still greater than or equal to the target, we'll have a smaller window. If it's not, we will go back to the top of the for loop, increment the end index, and make the window wider. Okay. At the end of the for loop, we got to return something. And what we're going to return depends on whether min length ever changed. So if min length is less than or equal to n, that means we were able to get we were able to find a working subarray. So we will return min length. If min length is greater than n, that means it never changed and we never found an array, in which case we'll return 0. All right, let's run it. Uh-oh. Network error. Please try reloading page. Okay, I don't really know what that was, but I think maybe it was because I wasn't signed in. Anyway, let's try it now. Run. What happened? All right, so that was accepted. Basic test case is accepted. Submit. Before I submit, I'm going to move the frame here, open it up so we can see what happens, and go. All right, 1 millisecond. Who beat that? 0.27, 0.27 solution. 80% of the solutions came in at 1 millisecond. Wow, even the memory was low. Okay. So that's it. Minimum size subarray. It's a sliding window technique. Good technique to know. Actually, there's a few more sliding window puzzles coming out. I peeked. So that's it. Feel free to like, subscribe, and see you next time.